Welcome to this episode of Seen and Solved. I'm your host, Tim Pennington, and today I'm joined by Jeremy Morgan, a product manager of biological products at Hubbard-Hall. This is the second of a three-part series that we're going to be having about biological wastewater treatment. And today, Jeremy, we're going to be talking about the major components of a wastewater treatment system. So thanks for joining us, first of all.
Oh, thank you for having me again, Tim. It's great to be here.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So major components. In our first episode, we talked about what it is, right? And like I mentioned to you, I hadn't really known that much about it. And you explained very well what it is and what it does. Let's talk about the components. And I say that because I know that a lot of operations, a lot of facilities are always worried about space, fitting things in. Can we drop things in? Do we need to buy a lot of equipment? Everything. But let's talk about what are the major components of a biological wastewater treatment system.
Simply put, the primary component would basically be a tank or a vessel to contain and hold the biomass. And that's going to be very similar footprint-wise, whether it's a conventional activated sludge system where the bacteria is suspended in the wastewater itself, or if it's a fixed film system where the bacteria basically grows on a surface. So that's number one. You have to have somewhere to hold the bugs.
This would be a new system. This would be a new tank, right? Would they have an existing tank, or would they probably need to get a brand new tank?
It depends. Ideally, it would be a brand new tank, freshly designed and plumbed to be able to handle, the new operation. But I've seen plenty of systems that have repurposed an old tank or an old basin and retrofitted it accordingly. So it just depends upon the design and the budget for that particular system. The second major component, most systems are going to be what we refer to as aerobic, meaning that the bacteria needs an oxygen source. They need air, basically. So you'll need some kind of what we refer to as a blower, basically, an air pump device that basically pumps air into the system. And that's going to be the same again, regardless of whether it's a fixed film system or a conventional system. You have to be able to give those little guys something to breathe. So you got to have an air source. And those air sources can vary. I've seen some small plants and shops that utilize basically their existing compressed air system, with some adjustments, of course, to get enough volume in there. But there are specialty blower devices that are designed specifically for wastewater treatment. Now, that being said, generally the finer the bubbles for the air that can be introduced to the system, the better. Basically, you don't want to just run a 3/8 inch piece of tubing down to the bottom of a tank. That's not really going to get you enough air in there. So you need some kind of diffusion device to be able to distribute it. And again, generally, the smaller those bubbles, the more access the bacteria have to the air. So that's the second major component. You gotta give those guys something to breathe. After that, there's several metrics that you really want to pay attention to make sure that the environment is right for the bacteria to grow and populate and do the removal job that you want them to do. Obviously, the amount of air that's in there, which we refer to as dissolved oxygen, or DO for short. There are specific meters and probes that measure the concentration of the oxygen in the system. So that's very critical. pH is also very critical, which most metal shops are going to be very very comfortable with pH.
Right. Mm-hmm. So they do every day. Yeah, definitely. Yeah.
Exactly. Now that being said, for pH, bacteria generally like a neutral pH, so somewhere around 7, and most systems are going to run somewhere between 7.0 to 8.0. After pH, other things like alkalinity can be very important to monitor. ORP can also be very important to monitor depending upon the components that you're trying to break down. So that third component is going to be overall your measurement devices. So those are critical along with the air and the component to a tank or basin to hold it. And then lastly, a lot of shops that already have an existing wastewater treatment system are going to be familiar with this too. But the bacteria being a kind of a living, breathing biomass, you do have to remove some of those generated solids from the biomass itself. So you have to be able to separate those solids, and ideally daily, you want to remove some of those solids every day. Basically, again, using the analogy that it's a living, breathing organism, you can get too much. So you can basically produce too many bacteria for the food sources that are available. So wasting out some of those solids every day is absolutely critical. So you do need to have a filter press or filter screen, something like that, rotary vacuum drum, something to be able to remove those solids from the system.
You mentioned a few things that, like you said, that need to be measured. Let's talk about that again here. So, and a lot of these are things that they're probably a finishing operation probably already has some degree of knowledge on how to measure that. But you mentioned pH and things like that. But what are all the things again that you said should be measured in a system to keep it running well?
Mm-hmm. Obviously pH, which most all systems are gonna be comfortable with that already. ORP is also a metric that I really like to look at, which kind of goes hand in hand with measuring dissolved oxygen. So ORP and DO measurements are kind of similar, but they are a little bit different. Basically, in low oxygen environments, dissolved oxygen measurement isn't very accurate, but ORP is. In addition to that, alkalinity can be a critical value to measure. If the system has to remove a lot of nitrogen or a lot of ammonia, the alkalinity measurement will basically the removal process for ammonia biologically consumes a lot of alkalinity. So there needs to be enough available alkalinity for the bacteria to be able to remove that ammonia. And those are the major components or metrics to measure, in addition to temperature. Bacteria do like to have a consistent temperature bracket that they live in, which is generally somewhere between 80 to 95 degrees Fahrenheit. So that's kind of their sweet spot. Once you start getting above, say, 110 Fahrenheit or below 55 degrees Fahrenheit, the environment changes enough that the bacteria tends not to be happy, particularly at those lower temperatures. The whole activity just slows way down. So temperature can be very important, but those are the basics as far as measurements go, in addition to the amount of biological solids that are in the system, so that you maintain consistency.
Right. And it seems like a lot of finishers have experience doing a lot of those things, temperature and the pH and those type of things. It seems like something that could really fit into a existing system that a shop would have. But is this really, I'm going to assume not a DIY project that they could do. I know a lot of them try to make their own tanks, their racks and everything. Is this something you would encourage them maybe to look at doing it themselves, or do they really need to buy a system that's really prefabricated and ready to go for them?
In certain circumstances, if it's low levels that are being removed, or just a slight polish, they can build their own system. There's nothing wrong with that. But for any new system, I would encourage the end user to, contact a system supplier or an engineering firm to really be able to design a proper system for them. Yes, it is certainly more expensive to do so, But the return on investment for a properly designed system can really keep them out of trouble, and in the long run, honestly save them money.
Gotcha. Yeah. Listen, Jeremy, this is great. Like I said, second part of our 3-part series. This was a great information on what actual are the components of a system, in case someone's wondering about putting it inside their plant. So I know we're going to be doing one very soon on basically how to run this operation, how to get training with it. But for now, I appreciate you giving us all that great information.
Thanks for having me, Tim. I've enjoyed being here.
The Scene in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit hubbardhall.com or wherever you get your podcast. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.